So this is second part of the tutorial on discriminative versus generative AI. Differences between generative and discriminative. Is a quick rundown of the major differences between generative and discriminative models. Generative models aim to capture the actual distribution of the classes in the dataset. Generative models predict the joint probability distribution utilizing Bayes' theorem. Generative models are computationally expensive compared to the discriminative models. Generative models are useful for unsupervised machine learning tasks. Generative models are impacted by the presence of outliers from more than discriminative models. Now, discriminative models model the decision boundary for the dataset classes. Discriminative models learn the conditional probability of y and x. Discriminative models are computationally cheap compared to generative models. Discriminative models are useful for supervised machine learning tasks. Discriminative models have the advantage of being more robust to outliers, unlike the generative models. Discriminative models are more robust to outliers compared to generative models. We'll now briefly explore some different examples of generative and discriminative machine learning models. Examples of generative models: linear discriminant analysis. LDA models function by estimating the variance and mean of the data for each class in the dataset. After the mean and variances for every class has been calculated, predictions can be made by estimating the probability that a given set of inputs belong to a given class. Hidden Markov models. Markov chains can be brought off as graphs with probability that indicate how likely it is that we will move from one point in the chain state to another state. Markov chains are used to determine the probability of moving from state J to state I, which can be denoted as PA by J, I, J. This is just the joint probability mentioned above. A hidden Markov model is where an invisible, unobservable Markov chain is used. Then data inputs are given to the model and the probabilities of the current state and the state immediately preceding it are used to calculate the most likely outcome. Bayesian networks. Bayesian networks are a type of probabilistic graphical model. They represent conditional dependencies between variables as represented by directed acyclic graph. In a Bayesian network, each edge of the graph represents a conditional dependency, and each node corresponds to a unique variable. These conditional independence for the unique relationship in the graph can be used to determine the joint distribution of the variable and calculate joint probability. In other words, a Bayesian network captures a subset of the independent relationship in a specific joint probability distribution. Once a Bayesian network has been created and properly defined with random variables, conditional relationship, and probability distribution known, it can be used to estimate the probability of events or outcomes. One of the most commonly used types of Bayesian network is a naive Bayes model. A naive Bayes model handles the challenges of calculating probability for data sets with many variables by treating all features as independent and from one another. Once a Bayesian network has been created and properly defined with random variables, conditional relationships, and probability distribution known, it can be used to estimate the probability of events or outcomes. One of the most commonly used types of Bayesian network is a naive Bayes model. A naive Bayes model handles the challenge of calculating probability for data set with many variables by treating all features as independent from one another. Examples of discriminative model. Support vector machines operate by drawing a decision boundary between data points, finding the decision boundary that best separates the different classes in the dataset. The SVM algorithm draws either lines or hyperplanes that separate points or two-dimensional spaces and 3D spaces respectively. SVM endeavors to find a line hyperplane that best separates the classes by trying to maximize the margin or the distance between the line hyperplane to the nearest point. SVM models can also be used on datasets that aren't linearly separable by using the kernel trick to identify non-linear decision boundaries. Logistic regression. Logistic regression is an algorithm that uses a log odds function to determine the probability of an input being in one of two states. A sigmoid function is used to squish the probability towards with 0 or 1. Probabilities greater than 0.5 are assumed to be class 1, while the probability 0.49 are lower, assumed to be 0. For this reason, logistic regression is typically used in binary classification problems. However, logistic regression can be applied to multi-class problems by using one versus all approach, creating a binary classification model for each class and determining the probability that an example is a target class or another class in the data set. Decision tree. Decision tree model functions by splitting a data set down into smaller and smaller points. And once the subsets can't be split any further, the result is a tree, this with nodes and leaves. Nodes in a decision tree are where decisions about data points are made using different filtering criteria. The leaves is a decision tree are the data points that have been classified. Decision tree algorithms can handle both numerical and categorical data, and splits in the tree based on specific variable features. Random forest. A random forest model is basically just a collection of decision trees where the predictions of the individual trees are averaged to come to a final decision. The random forest algorithm selects observations and features randomly, building the individual tree based on these sections. Thank you.